In today's video, we'll be going through the process of how to convert from polar to Cartesian equations, as well as how to convert Cartesian equations into polar equations. Well, the first thing we need to remember are our base equations, which as you can see are x equals r cosine theta, y equals r sine theta, r squared equals x squared plus y squared, as well as tan of theta equals y over x. Now let's go ahead and do some practice problems using these base equations. Well, the first practice problems we have say that we are converting between Cartesian and polar equations. Well, now we have our first problem which says x squared plus y squared equals 64. Well, let's go back to our base equations, see if anything matches up, or we can substitute anything to do this equation. Well, we can see that r squared equals x squared plus y squared, so we can substitute our x squared and y squared for r squared. So our new equation will look like r squared equals 64, and we just need to isolate r. So we know r equals 8 because we take the square root of both sides. The square root of r squared equals r, and the square root of 64 equals 8. So that means we have r equals 8, and that is our answer for number 1. Now let's go ahead to number 2. Well, number 2 says y equals negative 2. Well, if we go back to our base equations, we know also that y equals r sine theta. Well, let's go ahead and substitute that in and see what we get. So now we have r sine of theta equaling negative 2. Well, now again, we want to isolate r because we are converting into a polar equation where r is our main value. So we're going to divide both sides by sine theta, or multiply both sides by 1 over sine theta, whatever you feel is easiest for you. So I'm going to do division. So we're going to divide both sides by sine of theta. So those eliminate on our left side. So we're left with r equals negative 2 over sine of theta. Negative 2 over sine of theta can also be written as r equals negative 2 times 1 over sine of theta. As we should know, 1 over sine theta is equivalent to cosecant. So we have r equals negative 2 cosecant, also known as CSC. So that is our final answer for number 2. Now let's go ahead and do number 3, which says x equals 5. Let's go back to our base equations again and see if we can substitute anything for x or 5. Well, if we look at our base equations, we know that x right here, our first base equation, equals r times cosine of theta. So let's go ahead and substitute r cosine theta for x. For problem number 3, well, we have r cosine of theta equals 5. Again, we want to isolate r. That's the main thing we're looking for a polar equation. So let's go ahead and divide by cosine of theta on both sides. We divide by that. So we get r equals 5 over cosine of theta, or you could have been multiplying by 1 over cosine, whatever is easiest for you. So this is basically just r equals 5 times 1 over cosine of theta. As we know, 1 over cosine of theta is just secant. So we have r equals 5 secant theta. And we should also add the theta for number 2, theta. Those are our answers for 2 and 3. Now let's go ahead and do number 4. Well, number 4 says x minus 4 squared plus y squared equals 16. Well, again, in this type of equation where it's polar, we need to just isolate the r value. Well, we can see that we don't have an r value just yet. Well, what we do need to do is expand this x minus 4 squared right here. Well, we know x minus 4 squared is just x squared minus 8x plus 16. That's in our parentheses. And then we're just adding y squared and then equals 16. Subtract 16 from both sides. 16 minus 16 is 0. 16 minus 16 is 0. Well, the equation that we are left with, or our new equation, is now x squared minus 8x plus y squared equals 0. Well, now what we need to realize is that we have an x value in our equation by itself. Well, let's go back to our base equations and see what x equals. Well, we said x equals r cosine of theta, so we can substitute that in for our x. So now we're going to have x squared. I'm just rewriting the whole equation. We're going to have x squared minus 8r cosine theta plus y squared equals 0. Well, now we brought the r into our equation, and that's what we need to isolate. Well, again, we just did this by substituting the value of x from our base equation into this equation right here. Now, we have x squared minus 8r cosine theta plus y squared equals 0. Well, now we also know that in our equation, we have x squared right here, and we also have y squared right here. So then we have x squared plus y squared, and as we know in our base equation that this equals r squared. Well, that means that we can just substitute this in for r squared. So we have r squared. So this means we really have r squared minus 8r cosine theta equals 0. We can see that both terms have an r. We can factor that out. So we have r times r minus 8 cosine of theta equals 0. And we just did this by taking out the r. Well, if we divide r squared by r, we have r. So that's why there's an r here. And if we divide the 8r cosine theta by r, we have 8 cosine theta. And so we just took the r right here. Well, now what we can do is we can say that, hey, we're going to use zero product property. So zero product property. And we can say that r equals 0 because this r. And then we have this r minus 8 cosine of theta equals 0. Now we just need to isolate for r. So we know r equals, add 8 cosine theta to both sides. R equals 8 cosine theta. And that's our answer for number 4. Finally, let's go to number 5 for the Cartesian two-polar problems. Well, 5 says we have x squared plus y squared equals 5y. Well, we know that x squared plus y squared equals r squared. As we can see in our basic equations, x squared plus y squared equals r squared. Okay, so we have r squared equals 5y. Well, now what we can do is set this equal to 0. Well, what we can do is r squared, subtract 5y from both sides, and this all equals 0. Well, now we know that y, if we look at our basic equations, we know that y is equal to r sine of theta. So we can substitute r sine of theta for our y value in this problem. So we are left with r squared minus 5r sine theta. Let's see on. Sine theta equals 0. And we can see, again, we have both r's. We can factor out r like we did in problem number 4. So we have r times r minus 5 sine of theta equals 0. Now we're going to do zero product property one more time. And we say r equals 0 and r minus 5 sine theta equals 0. Add 5 sine theta to both sides. And we're left with r equals 5 sine theta, and that is our answer for this problem. Now we are going to go ahead and do polar to Cartesian conversions with the same types of basic equations. And now we're just going to be working backwards. Well, number 1 says we have r equals 5 sine of theta. Well, since we're going to a Cartesian equation, what we need to do is get an x and a y and try to get rid of that r. Well, what we need to do in this one is we can see that we have something really, really close to that our y value equation, which was y equals r sine theta. Well, we have 5 sine of theta. Well, if we have an r right here, we would be able to substitute in our y value, and that would make it much easier. Well, we can do that. We'll just multiply both sides by r. So we have r times r. So we have r times r equals r times 5 sine of theta. And this would lead to r squared equals 5r sine of theta. And again, we said y equals r sine of theta in our beginning. And I can show you right now. We said y equals r sine theta. Let's go ahead and substitute in y for our sine theta value, or r sine theta value now. So we are left with r squared equals 5y. Let's go ahead and set this equal to 0. We're going to get r squared minus 5y equals 0. And we also know that r squared is equal to x squared plus y squared. So we have x squared plus y squared minus 5y equals 0. Now what we have to do is try to set this equal to 0, right? Well, what we need to do is complete the square. So we have x squared plus y squared minus 5y. And our third term is going to be our b value, or 5. For the y's, are 5 or negative 5 over 2. So we have minus 5 over 2. And remember, when completing the square, you have to just square this third term and add it to both sides. And remember, this is equal to 0, so we can just add what we just squared. So negative 5 over 2 squared. And so we should be left with x squared plus y squared minus 5 over 2 squared equals negative 5 over 2 squared is just 25 over 4, so we can have equals 25 over 4. And then we can see that both terms in our parentheses are squared, so we can go ahead and rewrite that. So we have x squared plus our whole parentheses squared, basically. So we have y squared minus 5 over 2. So we have y minus 5 over 2 squared equals 25 over 4. And then this is your final answer for problem 1 on polar to Cartesian conversions. Next, we have the problem which says r equals 5. Well, if r equals 5, well, if you remember that r squared equals x squared plus y squared, we know that r equals the square root of x squared plus y squared. So this just means that 5 equals the square root of x squared plus y squared. But remember, it's not just going to be 5 because we squared our r. And since r equals 5, it's really going to be 25. So now we have 25 equals the square root of x squared plus y squared. Well, now for number 2, we need to remember that r squared equals x squared plus y squared. Well, if you remember that r squared, so we have r squared equals x squared plus y squared. Well, we know that we have r equals 5. So if we square 5 and r, we'll be able to get this equation. So let's do that. So we have r squared equals 25. Since r squared equals 25, we can substitute that in to this equation right here, which is one of our base equations. So we have 25 equals x squared plus y squared. Well, we need to isolate for y squared. So what we do is we do 25 minus x squared equals y squared. Well, now the only thing we have left to do is to take the square root. So we take the square root of both sides. So we need to isolate y. So we have y equals the square root, because we take the square root of y, equals the square root of 25 minus x squared. We know that if we take the square root of 25, we get 5, and we take the square root of x squared, we get x. We have minus x equals 5. 5 minus x equals y, and that is our final answer for number 2. Finally, we have number 3, which is r equals -4 cosecant theta. Well, we said that cosecant, CSC, equals 1 over sine of theta. So in reality, we have r equals -4 times 1 over sine theta. Now, what we need to do is get our value. Well, we know that if we multiply both sides by sine theta, we should be able to get helped. So we have multiply by sine theta over sine theta. So we have sine theta over sine of theta. Well, we have to multiply both sides by sine theta. So we have r times sine of theta equals -4. And remember, we said that r sine of theta is just equal to y. If we look back at our base equation, scroll all the way up, we said r sine of theta equals y. Well, that's what we just got. So that means we know that y equals -4, and then that's our final answer from going from a polar to a Cartesian equation for this last part. Well, I hope this video helped, and if you believe it did, please consider to like and subscribe. I would greatly appreciate it. We have passed 100 subs. I greatly appreciate all the support the channel has been getting. Thank you guys so much. Again, please comment and like if this video helped. Hit the bell notification button for future updates, and definitely follow the Instagram. Thank you.